start today the Scala Essential series, which we have created aimed basically for newbies. We will start with the topic pattern matching and case classes, which was also the very first topic of our community back in September 2011 at our first talk, when we were sitting 7 people in a cafe colore with this little notebook. So I have revamped the talk for you. We'll have completely new slides with some fancy superheroes pictures, and I have added the case classes topic. The pattern matching is a very strong and very sexy feature of Scala, brought to Scala from ML, family of languages. And case classes is very good complementing concept, so we will get it together. As I said, this Scala Essentials is aimed for beginners and intermediates, but that doesn't mean it will be superficial. We will dive deep into the Scala internals of these concepts and learn about some perils which you might meet across. I will give the talk in English, even if there is no non-Czech speaker in the audience, because this is taken to the video and will go on our YouTube channel, and many members of our community don't speak Czech. So I guess you don't have a problem with that. So we go international. Okay, if you are about to code today, there will be no separate coding session. You are supposed to code during the talk and try out the snippets of code which are within the slides. The slides consist almost solely from code, besides the fancy superheroes pictures. So if you download this gist, there are some case classes and some model created for you, so you can start easily rewriting these examples. If you didn't make it, there will be one more opportunity to rewrite the gist URL. Okay, so what is a pattern matching? Is there anyone of you who is not aware or not familiar with this concept? Don't know at all what it means? Or everybody thinks, okay, I know pattern matching a bit. Okay, thank you. So, pattern matching, as I said, is a very powerful concept, and I'm showing you its very simple use, which is similar to a switch statement in Java. On the left side, you have a switch statement, on the right side. It's a match expression written in Scala, which is equivalent code. Here is some expression, in this case it's probably a variable, the match keyword, and a block of branches. And each branch matches, or the expression, its result is matched against some constant, and the match expression returns a value of the matched branch. So it is very similar concept to the switch statement in Java. But you may spot a couple of differences. The main one is that switch statement is a statement. It doesn't return a value. It does something. It runs a procedure or a piece of code within the branch. While match expression is an expression. It returns a value. The values of the matched branch. The first one, the first branch which is matched, gives the return value. So that means there is no need for this break keyword. So it makes your code a bit shorter. It's nice. And the main difference is that the case expression is much more than that. It is very often named as a Java switch on steroids. I like the on steroids metaphor because it allows you to bring nasty pictures on your slides. But as I stated in the invitation to this event, that would be our statement. The case expression, the match expression, pattern matching is much more than that. It's rather a Batman's tool belt. There's a lot of tools you may use, not just for matching again constants, because in switch statement in Java you may use only literals of primitive types, the enumerations, and newly in Java 7 also strings. With match expression you may use much more than that. So I will show you a more complicated example. Here is a model. It is the content of the digits here. So if you got interested by the topic of superheroes, there's a last opportunity to download the gist. And there is beside it, we have a trait named character, which is a name of string. And it has two subtypes or subclasses. A civilian, which is a name and some wealth. And a superhero, which is a name, a list of superpowers, and an alter ego, which is an option of civilian. You know some examples? Who's Batman's alter ego? Who knows?
Bruce Wayne.
It's Bruce Wayne. And what is Bruce Wayne's wealth? He's a very rich man. You've seen the movies. It's a fortune. So let's have this model in Scala, and let's have this problem. Suppose you have a variable of a character trait, some person, which might be a civilian or a superhero, and you want to know its superpowers if the person is a superhero and its alter ego is Tony Stark. This is a idiomatic Java code you would have written to solve this problem, to get this power. You see it's a lot of boilerplate. You check the type of the unknown character. If it's a superhero, you typecast it. Then you check if its alter ego is Tony Stark, and if it does, you can return hero's powers. Otherwise you return null, otherwise you return null. So it's quite a long code. Yes, I have cheated a little bit. It could be shorter using, for example, eternary operators. But this is what you usually do. How many times the superhero type name is used in this code? Can you count that? Okay. How many times?
3 times.
It's 3 times. Is it a superhero? If it is, then it is a superhero. You know, a superhero. While in Scala, you can type it just once. This is almost identical code to the Java version, and this is the match expression again. But see, in the case clause, in the branch, there is no constant to match against. There is a pattern. You say, if the person looks like this, that is, it is a superhero, we don't really care about its names, give us its powers, and check if the alter ego is some Tony Stark. Then get the powers. Otherwise, return none. There is actually 4 types of patterns used, and during the talk we will learn about each of them. So, how do you like it?
It's easier. For me, it's easier. It's like it's clear.
It's clear to read. Yes.
Yeah,
it's more intuitive.
I have no idea what it means.
Yeah, sorry.
I have no idea what it means.
Okay, you will learn it in this lecture. I have shown you almost everything, and now we will go through each of these patterns, the atomic patterns, and how to compose them. So this is rather complicated example, but at the end of the lecture you are supposed to read it as a mother language. It's needed to say that the pattern matching is very powerful, especially in statically typed languages, because you might guess that in the dynamically typed languages there is no need for it, which even show the code. You don't really care about the type because there is none. So, well, there is only one pattern into the mounting of Polver in the Ember series. There is multiple patterns in the Scala pattern matching, and we will go through each of them in the next minute. So this is the most basic, most common pattern called wildcard pattern. And that means match anything. Doesn't matter what it is, it always matches, always yields true. So if you write this code, what does it do? What does it return? A string called anything. So you gain almost nothing with this code alone, but the wildcard pattern is usually used as a default branch. Another basic pattern is a constant pattern, which is similar to the switch statement. You may use any constant like integer or string, or any object of any kind. And here is the wildcard pattern, which serves as a default branch. So if this variable does not match what you do, hello or mathp, it will match always the wildcard. So the branches are always evaluated in the order they are written. So it's more intuitive. Questions? It's easy, isn't it? Okay. I spoiled it. What happens in Java if you leave out the default branch and the expression doesn't match any branch? What happens? Who knows it? Is skipped? Yes?
It does nothing.
It does nothing. Yes. In Java, if you leave out the default branch and this expression doesn't match any other branch, it does nothing. What does Scala do if you leave out the default branch and the expression is not matched against any of the branches? It's an expression, it has to return something. So what does it return?
Exception.
An exception. The correct answer is it returns nothing too. But it is completely different nothing than the Java nothing. In Scala, there is a special type which is called nothing, and is a subtype of any type in Scala's type system. Integer, superhero, you name it. And if you say that your function returns nothing, that means that the function will never end. It will be interrupted with something. For example, it may turn on the turn of the JVM or throw an exception. So if it throws an exception, it conceptually returns nothing. That is different from a function that returns so-called unit. Let's say we have this function. Can you read it? Do you see it? What's there?
Not much.
Try different. It's better. what does this function return? Who knows it? In Java, you will have something like this. It's equivalent. This keyword means that the function has no return type and it returns nothing. But in Scala, it has a type, it's called unit, and it returns the unit's only value, which is empty parenthesis, and that means something like I have ended. It returns one value, I have ended. The value usually has no special use, but it returns something. But nothing means the function does not return nothing, even the unit value. So it happens only in two cases. One of them is throwing an exception, and that is exactly what a match expression does when you don't match anything. It shows an exception which is called match error. And the compiler is clever enough if it spots that there is a possibility, the theoretical possibility, that this expression does not match anything. It will tell you. It will emit a warning. You would better add a default branch, otherwise you might end up with a match error exception. And sometimes the compiler is able to spot that there is no such possibility, then all of the cases are covered with your branches, and we'll see that later how to achieve it. So this is about the match error. Everything clear? So do you understand the concept of nothing? It's rather peculiar, it's from the type theory. It's maybe used in Haskell, I think. Such kind of type, not entirely sure, but it's not in the mainstream languages like C or Java. So another pattern is variable pattern. It's like the wildcard pattern. It also matches anything and creates a new variable with this name for this anything. So in this rather useless code, you will create a new variable something which will contain the value of what is this. What would be the type of something variable? We know that. Haven't heard anything? Any? Some? It will be the same type as this one's. If this is an integer, then something will be an integer 2. If it is an any, something will be any 2. It's the same time. So yes, in this case, it looks like it's almost useless, but we will see later that the patterns compose, and we will make use of it. Okay, so what happens in this case? There is, what is it? Twice. Is this. What do you think that will happen in this code? What is this? What is the stupid name? This will create new variable called what is this, which will shadow the original variable. What is this? In this case, it's pretty obvious this is totally useless, but it might happen too in the real world, real life, if this name will shadow some other variable in scope. And you might not notice it. Compiler should warn you, and some modern IDEs like IntelliJ, Scala plugin will warn you that there is some suspicious variable shadowing. You should take care of it. So it's not wrong, just might make some mistakes because you don't need to be aware of this thing. So another pattern is a typed pattern. It will match anything of the particular type and creates a new variable of this type and put this content into the variable. So if what is this is an integer, a variable n is created of type integer, and this branch matches. And if it's not an integer, then another branch is matched. If it is a character, new variable c is created, and the what is this content is put into it. So this is the case when you save a lot of boilerplate you would write in Java. For this type of thing, you would have either write a visitor pattern or write a lot of instance of code. Questions? So let's get back to the original code. I'll show you it's a Tony Stark character. This is named a constructor pattern, and it's in this shape here. Is a name of a constructor, the class superhero, and behind it are 3 nested patterns for each of superhero's parameter. So if you recall, the first superhero class parameter is name. What does this mean, the underscore letter? What does it mean?
Like anything or something like that? It's like no.
Yes, any name will match this pattern. So we say we don't really care about the superhero's name because we want to match anything. What is this? The powers. What kind of pattern is it? It's a variable pattern. So what does it mean? What does it match? It matches anything again and creates a new variable and puts the second parameter of the class superhero into it. So this is how we extract the powers attribute, the powers field from this instance. And what is this pattern?
Type.
I'm sorry?
Type.
Type pattern? No. Type pattern is written with a colon and type name. So again, it's a nested constructor pattern, constructor sum, and inside of it is a value Tony Stark. So that would be constant pattern. We assume that the Tony Stark it is a constant. There is only one Tony Stark, you know. So this branch matches any value that is of type superhero. Its first attribute name is anything, we don't care. Its second attribute powers is anything again, but we want to extract it. And the third parameter is some Tony Stark. And if all these conditions hold, then the branch matches and we get some powers. Otherwise, we get none. So this is constructor pattern. This is how the patterns nest to each other. You can nest it to any depth and level. So, did you get constructor pattern?
Yes.
Cool. Let me ask you one thing. This is variable patterns. Lexically, it is an identifier, a bunch of letters. This, I have told you, I might have misguided you, is a constant pattern. Lexically, it is an identifier again. How the hell does the compiler know if this is a constant pattern, this is a variable pattern? Something doesn't add up here. Yes, I have made this italic and blue, but the compiler doesn't really know that. Let me show an example with more context. Let's say we have a Tony Stark, you know, he has a fortune, Bruce Wayne, against a rich man, and this poor journalist Clark Kent, some cash in the pocket. And we will match Tony Stark against these three branches. And you can see it bare naked. Bruce Wayne, bunch of letters. Clark Kent, bunch of letters. There is some reason why it's not italicized and blue. Can you spot the difference? What does this expression return? Who knows? Is he? Does anyone have another opinion? What does this expression return?
Isn't this Superman?
Isn't this Superman? With a question mark, because it isn't. So it's Stark, it's an Iron Man. So again, can you spot the difference? Forget about the colors of the code.
First letter case.
Yes. If the first letter is an uppercase, then it's a constant pattern. And when it's a lowercase, it's a variable pattern. Why is that? That's weird. We have this kind of rule in the grammar. It's in the grammar of the language, which is case sensitive and doesn't really care about the case instead of the keywords. So why would the language authors choose such a thing? It doesn't really matter if this is a vowel or object or whatever. It really matters if it's uppercase or lowercase, the first letter.
It's customary to write constants with a first letter capitalized.
Yes.
Sometimes with all letters capitalized, or in Scala most typically with the first, with the camel case.
Yes, yes. We want to have both choices, the variable pattern and the constant pattern. And both of them are lexically an identifier, bunch of letters. So the authors of the language could have chosen one way to differentiate between these two rules with some another kind of symbol, some other kind of keyword which would clutter the code, or what did they choose actually was to depend on the convention. And conventionally, the constants, and again, it doesn't matter if it's a vowel or an object, start with an uppercase letter. It's a convention, and it's widely used, and you very rarely see a code that doesn't follow this convention. And the variables, like in Java or C#, are written with a lowercase first letter. So they chose to depend on this widely accepted convention. And again, it's very rarely seen any code in Scala doesn't follow this convention. It's even codified on the docs.scala.org webpage. But you need to be aware of this. You need to know it. It's weird, but it works. And if you have an intelligent IDE like IntelliJ, in this particular case, it will tell you, hey, there is a suspicious variable shadowing. So this branch does not match Clark Kent. It matches anything and creates a new variable Clark Kent, which shadows this one. and the IDE will tell you there is something, there's some smell in your code. Look at it. So it's good. If you want to match Clark Kent, which is lowercase, what would you do?
Create another variable.
Create another variable with uppercase, or use this, the backticks.
So it's like it will. What does it do? Like evaluate this expression or something like that?
No, the backticks will tell the lexer this is a constant pattern.
Looks
It's
like
a special meaning. The backticks have two meanings, and this is one of them. This is a constant pattern.
it looks like PHP.
Like PHP.
Yeah.
Yeah. Scala is inspired by middle languages.
Oh yeah. It's a question whether it's good or not. Okay.
No, this is a trade-off. They chose to spare one extra keyword to differentiate between constant pattern and variable pattern. Chose a nicer code, but which needs to follow conventions.
Okay. So if you want to access the Clark Kent variable inside the match, you have to use the
Backticks,
Yeah.
yes. And this will not match anything. It will not create new variable. It will tell this is a constant pattern. This Clark Kent. So in this case, Tony Stark will not match anything, and this anybody.
Okay.
Jesus Christ, it's humiliating. So we will see this little guy a couple of times during this talk. This is the first instance, and it means there is something we need to be aware of, which is not very nice. But this is how Scala is done. Yeah, we will see this guy again very soon. The constructor pattern. We're still talking about constructor pattern. This one we already know. We understand it. And now we will match the powers, which we will get, against this peculiar pattern. Who knows what kind of pattern this is? I haven't told you yet. This is a constructor pattern, the constructor sum, and inside it some value. And what is this?
I would think it will just leave the first, like the head element out of it. If it's the power, I would say it's some kind of list, something like that. I don't know, maybe it's a calling or function, rest.
Orange. Intuitively, it will match a list and its first element put into the power, and the rest, I have chosen good name for this variable, will put to the variable rest. So intuitively, it will pattern match a list. But from the point of grammar, this is constructor pattern too. And it is actually a syntactic sugar for this. If the constructor has exactly two parameters, you can write it with the infix notation like this. And as far as I know, it is used in the majority of cases with exactly this constructor, which is named cons. It was inspired by many languages, and the first one who used it with a different name was Lisp back in the 50s. So this is actually a constructor pattern. There really exists a constructor which is named colon, pronounced cons, and it is a syntactic sugar for this kind of thing. The way why the language authors chose to display it like this is the intuition, because the colon is also a function, and on the different places you may use this code for instantiate lists. So for example, this one's good if you write one const to const nil. It is the same as if you have written this. This is nicer. This is not. That is nicer. This is not. So it's just a syntactic sugar, and most of the time you will use it with this operator, this constructor, in this case, to match lists. And if you study the Coursera course, you might have probably used it a lot of times. So again, it's a stuff you need to be aware of. It's a constructor pattern. It's not a special syntax. It's not a special type of pattern. And actually, you are free to construct your own patterns like this. The only rule is to have 2 parameters exactly. Questions? We will see this guy again. So a tuple pattern will match if this variable is a tuple with 3 elements. First one is 42, is a constant pattern. Second one is written in English, pi, p, pi. And the third one, we don't really care. The other will match against Ironman and Mandarin. And this one is actually a constructor pattern. So the tuple pattern and constructor pattern are very close to each other. What happened here? What kind of pattern is this? The fourth branch.
Let's say it's kind of a sequence of elements. Maybe let's first this
Sequence of elements. Yes, yes. This is a tuple pattern. The first element is matched against any villain, and the second element of the tuple is matched against Mary Jane. In this case, the villain is Magneto. So there's a tuple pattern.
And what's the mechanism of the evaluation of this pattern?
The last case.
Of the last one. When a pair is something.
If it is a tuple,
Yes.
then extract its first value, and if it's a villain, put it into the v variable. If it's not, then skip this pattern. If it is, then match the second element of the tuple with Mary Jane. If it is,
Okay.
match. If it's not, match error.
Okay.
So you see, you can nest the patterns as you see fit. And the resulting code is very, very terse and very intuitive. There is another type of pattern, a sequence pattern. It might look like this. This will match if powers is a list whose first element is super strength. There is some second element, but we don't care about it, but there is some second element. And there is 0 or more other elements, we don't care again. So this will match at least 2 element list or more, with the first element being a value of super strength. So in this case, what makes it a sequence pattern usually is this kind of symbol. But you will learn it not really. If it's there, it must be a sequence pattern. If it's not there, we need to know how to distinguish, and we will later. So, any questions to the sequence pattern? It can be used against sets or maps, because sets and maps are not sequences. It can be used solely against sequences. So if you want to check if some set has certain elements, you're free to use the contains method, but the sequence pattern is used for a sequence, and you may match each of the elements against its own pattern. I will show you later a more complex example using sequence patterns. So are you okay with that?
What's the difference between the sequence pattern and constructor pattern? Because this looks like constructing pattern of type list, isn't it?
Yes. The difference is that in the sequence pattern there might be a list with any length, with any number of parameters. But the constructor pattern matches the arguments of the constructor one by one, and it's a fixed number. So if you have a superhero which has 3 parameters, you may use only the three patterns. But in the sequence pattern, you may use any number of patterns which matches any number of elements.
So in Scala, there is not possible to have constructor with variable number of arguments. It is not possible in Scala.
It is possible. That's a good question. Let's rewrite our superhero. And the name of type string and powers. In Java, you would have written Java. Where are the 3 dots? Is here or here?
After the type.
Huh?
After the type.
Here.
Actually, I think it's after the name.
It's here. Yeah. I'm not sure. So this means there is a variable number of parameters. Denoted by the star in Java it's 3 dots. So it's the same. And under the hoods there is a sequence. And you will probably pattern match it. I haven't used it before, but probably somebody who has Scala on your notebook, you might check it. And here is the sequence pattern inside of it. This will probably work. Other questions to sequences? We will see them again later. These are actually all kind of patterns available in Scala. I think I haven't forgotten any one. There are some other things you may use in a match expression. One of them is a pattern guard. Here we match against the civilian. We don't care about his name. And we want its wealth to be cash. We extract the amount of the cash of the civilian into the variable of money, which is created for us. what would be the type of money in this case?
Integer.
Integer. Why integer? I don't see any integer. Why integer?
Because it's an expected value.
It's
It's something like you would know before.
It's defined in cache.
It's defined in the cache class. The cache class has one parameter with some name of type of integer. So the type inferencer will infer the type for you. It will create a money of type integer because there is no other way. And you may, sorry, there is a typo. This should be money, not cash. You can put an if expression, if clause, and it's still in the definition of the branch. So it's not a nested if expression. It's a part of the pattern. So this will match a civilian whose cash is at least 10,000. And then it matches and returns a rich guy. You may use any expression here, and you may use all variables you have extracted in the pattern before the if keyword. You may notice that there is no need for parentheses, unlike in the usual if expression. It's one of the small inconsistencies that is about to be fixed in future releases of Scala. So, you find it useful? You know what it's used for? How it works? Questions?
Shouldn't be there instead of cash money.
Yes. There's a typo. Thank you, Karel. Okay, so that will be it. This is pattern matching, and it's used in a match expression. But there are more uses of pattern matching in Scala. The match expression is only one of them. You may use pattern matching in multiple places. And this is first one. You may use patterns in variable definition. So let's see the first one. Let's assume that this is a tuple, and this is a tuple pattern combined with variable patterns. So this will extract the tuple components fields into a variable A, the first one, and B, the second one. The types are on here. They are inferred from the type of this variable. What does this first line do if the sum tuple is not a tuple? If it's a string, or a tuple with 3 elements, or a list, what does it do?
Exception.
Yes, it will throw a major exception. But the compiler doesn't warn you. This is your responsibility to check it. The other, again, is a sequence pattern with a list. There is some list, and we assume its first element is a flight. We want to know its second element. We extract it to the second variable, which is created for us. And this is a new kind of symbol. This is the pattern for the rest. And this edge symbol will create a variable rest where the content of this is put into. So sometimes you may use an inner pattern, a nested pattern, and want the whole have in another variable. So like this. I can put another example, which might be clearer. we had a civilian. So this pattern will match a civilian whose name is Clark Kent and whose wealth is a cash, and it will extract from the cash the amount, and the whole cash will put into the new variable cash. So in amount is of type integer, and this variable is of type cash. The whole expression is here. So this is what the edge symbol is used to. And here again is a constructor pattern. So it will not match a civilian whose wealth is a fortune, which is a different type from cash. There's a type pattern inside. So as you can see, you may use pattern matching also in variable definitions, and it will save you some unneeded code. So is this pattern matching too? This is a normal variable definition. Is it considered pattern matching? What do you say? Yes and no. From the compiler, no. Of course, that would be an overhead. But conceptually, it is consistent with the rest of the pattern matching. So no is not pattern matching, but it might look like a variable pattern. Another use of pattern matching is in a try-catch expression. In the catch clause, you put branches like in pattern matching. Most of the time, you use the variable pattern, which matches the exception of the correct type, but you are free to use any kind of pattern you know. If the exception is a case class, you may extract its parameters via constructor pattern, for example. So this is another use. So as you can see, if you are learning the try-catch expression, you are not learning new syntax. You already know this syntax from the pattern matching examples. Here is another use case of pattern matching, and it's called partial function. What is a partial function? What does it mean?
It's not a total function.
Yes, and what does it mean?
It's not defined as the whole set of inputs.
Yes, it is not defined for each possible value of its parameters. So this is partial function that takes a parameter of integer and returns a string. But this particular function can accept only value 8 and 10. It's defined only for these two values. The partial function type is defined at method for you, which will yield true if this value is here. So what will return this line? It will return false, because this particular function is not defined for 12. And what would happen here? What? Exception. It would be a match error. Or invalid argument, match error. Which match error? Match error. Because this kind of syntax is compiled into an instance of a partial function with two methods. Is defined at, which has a match expression inside with these branches, and each of it return true. And the default branch, which is therefore you, return false. And then it implements an addLine method, which again has this block inside of it. So actually, this kind of code is again syntactic sugar for defining a partial function, which actually creates two very similar match expressions in two methods. Okay. And the last one is a for comprehension. So I have created this example from real life for you. It was some problem on one Coursera course about implementing a Dijkstra algorithm, and the graph was in this kind of format. So on each line is one node. This is the name of the node, and with the tabulator characters are edges. The first number is the target node, and the second number is the edges weight. And this kind of short code parses this kind of data into some model, so you could traverse it with your algorithm. So what will happen here? This is a for expression, and for each line in lines, split that line, and this function returns an array of strings. And I will pattern match the array, take the first one as a source node, so it's the number 1, 2, or 3 in this example, and the rest of it put into the edges variable. There might be variable number of edges. I have put just 2 of them in the example, but there might be much more. Or not at all. And for each edge, inside of the edges, you can see there is no type information inside, but it's inferred by the compiler for you. The lines is a list of string. Therefore, line is a string. String has a method split, which returns an array of string. So source node has to be string, and edges is some sequence of strings. Therefore, edge is string again, which is a method split. And I know from the format that it has a constant length of 2 elements. The first one is the destination node of type string, and a length is the second element of type string. If I would put one more comma at this place, what will happen? Shows an exception, the match error. No.
It will be...
No. If the pattern does not match, it's ignored. You remember the little guy? He saw the camera. So, this is sequence pattern. And how is it different from the constructor pattern? How the compiler knows this is a sequence pattern, because it looks totally like a constructor pattern. We will learn later. So, did you get this example? This is for comprehension using patterns. And you may use any pattern you have learned in here. But there is one pattern that is a little bit different that you have learned, and it's a variable pattern. If you write this, what you would have expected, what you would expect, spoiled the point. If this comment is not here, what you would expect?
You mentioned the superheroes.
Yes, there is a bunch of characters. You know that character might be civilian, a superhero, or a villain. But it matches only superheroes. And for each superhero, it returns his alter ego. And if it's not a superhero, it will skip it. If for comprehension does not throw match error, if it doesn't match the pattern, it will skip it. It's different behavior. But this just does not compile. You have to write it like this. This is again a language inconsistency. I'm not really sure about the reason. There is a ticket somewhere in the Scala authors. I know what they use. I'm not really sure. It still doesn't work in Scala 2.10.1. So if you want to filter characters against superheroes, you need to write this syntax. It's better to be evaluated beforehand if you don't need to struggle with this kind of thing while having a deadline. So, everything clear? I promise we are seeing this guy for the last time. And now we are seeing another guy. Do you know who it is? Have you watched the Heroes TV show? It's probably 5 or 6 years ago.
Nasty guy.
He's a nasty guy, Scala. He's able to extract your superpower. But he needs to first eat your brain. And we have extractors too in Scala. It's not that invasive. They do not eat your brain. We have another trait, person, which have two methods, name and age. Name is string and age int. And we would be happy to pattern match it like this. But there is no constructor named person. Person is trait. It's on the class. It doesn't have fields of type string and age. It's a method. It could be implemented in any way you can imagine. And this kind of stuff, as I have said, works only for case classes. And it's not even a class. But, you know, it would be nice, this kind of code. It would be, at least in this case, it would be intuitive, wouldn't it? And there is a way how to achieve it, and it's called an extractor. And it's done like this. You define an object with some name. I have chosen the same name as the trait, but I didn't have to. I could have chosen another name. And I define an unapply method. It's a magic name, remember it, which takes a parameter of type person. It's this person, the trait person, and returns an option of a tuple of a string and integer. And in this particular case, it will just extract its name and age. There's a typo again, sorry, person.age, and returns some tuple, person name, person age. It's a very simple implementation, but very straightforward. And in this case, we might write this kind of pattern. So it is constructor pattern. And the way how constructor pattern really works is that it finds an object with this name and looks for an unapply method which takes this and returns a tuple. And if it returns none, it does not match. And if it returns some tuple, it will pattern match the tuple with what is inside here. So this is exactly what you have to do if you are matching against a thing that is not a case class. You are free to write your own unapply method. And there are several types of unapply methods. I didn't put it in my slides because I'm in a hurry. There's more slides to go. But you can create magic against just one parameter or many parameters, and you are even able to define an unapply seek method which will create the sequence pattern. Can we write it on the board? If you implement this, whenever type, which returns an option of sequence of something, let's say string or integer or any or whatever you may choose. Sorry, unapply. Sequel, it has to be the part of the name. You have just created a sequence pattern. So this is how compiler knows if it is a constructor pattern or sequence pattern. It's either the unapply method or the unapply seeker method. So these are two magic names you have to remember if you want to create your own constructor or sequence patterns for a data you want to pattern match in this nice way. Do you understand extractors?
A little bit.
I'm sorry?
Just saying a little bit.
Okay. Once more. Yes?
It will works if someone change order. If age is first and name is second.
It doesn't matter here. It matters here.
Yeah.
This is not matched against this. It's matched against this tuple. So if a compiler spots a constructor pattern in a case clause of a match expression, it will first look for something with this name, usually an object, but not really, always, usually an object, and looks for an unapply method or unapply sequel method, which takes an argument of this type, at least. It might take any, or it might take person. So if this would be of type any, it wouldn't even compile. And the unapply method returns option of something, usually a tuple, but it might be something else too. And it will pattern match this content between the parentheses against the tuple if the unapply method returns something. So this will compile into if this unapplied this is sum, then pattern match it, and if it pattern matches the tuple, then the whole branch matches. So in the end, it will produce a lot of code which we do not see. And there's a lot going on here. We just write it in a very, very short and intuitive way. But this is exactly what will happen. We'll call the unapply method. And if it's not there, it will not compile. Is that clearer? And you may really match again anything. I have put here example with a person with two methods. But it might be a string, any string, and you might create an extractor called email, which will parse the string, and if it's in the format of email with the @ sign and letters and numbers and whatsoever, it can extract you whatever you want. So you may really use extractors for whatever. Here can be whatever, and here is option of tuple of whatever. And you are able to extract the data from the variable of whatever type. That is why it's called extractors. It will extract data for you, and it does not eat your brain. I hope. So as I said, there is more kinds of extractor. You may return boolean, you may return only one value or multiple. More. Yes? Okay. I thought you had to say something. So that will be for the pattern matching part. Any questions for pattern matching? Are your brains still in your heads? So now we go to the most sexiest part of a Scala, and it's case classes. We have already started our example with case classes, and I haven't even explained what it is. Where does the case word come from? It's the pattern matching expression. Case, something, and the case classes are used in pattern matching very often. You don't need to have write its unapply method. You want to go to the next slide? The lady will disappear. So, if you put a magic case keyword in front of your class definition, there is a couple of extra lunch you get. The first one, there is no need to write this val keyword. Is there anybody who doesn't know what it means if you write class villain val name string? Is there anybody who doesn't know what it means? Okay. What's inside the parentheses are parameters of the constructor. In Java, you write its own function with the same name as the class name, which is a constructor. In Scala, the whole body of the class is the constructor, so there is no need to write a separate function for it. And these are the parameters of the constructor. And if you put a val in front of the parameter, it will also create a field, an immutable field, something like final. So it's just 3 letters, 4 keystrokes, including the space, and you get another field. And the value of this parameter is put into the field while creation. So in Java, you would have written, do we have time? We'll take a couple of minutes. Time. In Java, you would have written public class person, public again, person again, sorry, string name, I will put just one here, yeah? This, name again, is name again, there will be name again, final, sorry, and there would be name again, and for a huge success, name again. You see, person, name. In Scala, you write just this. String. That is the same. So, this is the class person. which constructor has a parameter of type name, it will create a private final string name, and it will create a getter called name, which will return the name field. And the constructor initializes it with its parameter. So this is essentially what is created for you if you write this code. This will happen under the hood. The JVM sees this. This is what you write. So with case classes, you may omit the word while, and it is the same. So case class always creates fields of the primary constructor for you and make them immutable. So you get this for free. Just one little keyword case. This is one benefit. Another one, when you instantiate the class, there is no need for the keyword new. We write it like this. What does this mean? Why would we have to spare this keyword? Does it make it any more readable, more intuitive? Why? It's not really a huge gain to say 4 keystrokes. I will tell you later. This is the reason. With the case class, also an equals method and a hash code method are created for you in a way that equals takes into account each of the class parameters and make a nested deep equals around all of its parameters. This kind of stuff you are writing all over again, or let your Eclipse IntelliJ IDE generate for you all over again. This is hidden in the case keyword. The equals method is created for you, and the consistent hash code is created for you. Somewhere deep inside the generated bytecode, there are 2 implementations, equals and hash code. And this brings us to the reason why you do not have to write a new keyword. Because if you write villain Mandarin 20 Stark, which is this arch enemy, and villain Mandarin 20 Stark, in the memory, these are 2 instances. But conceptually, this is the same value because they are equal to each other. So you would create a case class. One of the reasons is that if you know that 2 instances with the same arguments, same values of parameters are the same, equals is created for you. And in this case, the new keyword will be actually confusing because it's new. It's not new villain. It's still the same one, the same Mandarin who hates Tony Stark. And yes, in the heap there are 2 Mandarins, but they are equal in the notion of the equals method. And there is also a hash code which is consistent with the equals, so you are free to use it. For example, like a key in the maps, and it will work. And how is it that you don't use the new keyword? Is a special kind of syntax? Does the compiler know there is no need for the new keyword? No. There is another magic method created for you. It is called apply. Everything that has an apply method could be written like this. The compiler, in this case, okay, x, y, what is it? Is it a function? If it is, call it with the parameter z. If it's not, does it have an apply method? And if it does, call it with the parameter z. This is what you write. This is what you get. And actually, a function has an apply method. So, if you create a case class villain, the compiler creates for you an object villain with the apply method, which has the same parameters as the case class, and calls the constructor for you. So this code is not creating new instance of villain, it is calling apply method on the villain object, and it will call the constructor for you. And this method is created for you by the compiler, so it's a part of free lunch. Another thing you get in a case class is a toString method. It will create a toString method that will put the class name, parentheses, and the values of the arguments. So if you are debugging the code with case classes and putting instances on console or logs, it will appear like this. It will be again very intuitive for you to debug it. So the toString method again is created for you. You're not finished. No more. You get a copy method too. Yes?
This is by default in the method hash code and
I think it's the Java implementations. So the default equals method compares references, and the default hash code takes the reference, I think, and converts into integer, I think. So these are descended from Java lang object. Okay. You know, Sixpack is a very famous superhero in a Hitman series. I'm kidding. This copy method will create a copy of the case class object, and you may change one of the parameters. So this is again created for you. The superhero, the case class, has all of its parameters final, so you can't change it. There is no setter method for it. So if you want to change it, you will create a copy and change only what you want, and the rest of it is copied from the original instance. So this is how the copy works, and again, this is created for you for free by the compiler, just like by putting the case keyword in front of the class. And the last one, pattern matching. You may use case class in pattern matching without providing your own unapply method. How is that? How does the pattern matching work for case classes for free? Who knows? It will create the unapply method for you. So again, it's an unapply method, like everything else, but it is created for you. So the list is pretty long. You get equals, you get hash code, you get toString, you get copy, you get apply, you get unapply, you get all of this just by putting one keyword, case class. You need to know everything of what you get for free, because I know a guy who created case classes just for the sake of not writing a new keyword. And his code stopped to work at some places when he compared two instances that didn't realize they were actually equal, even if he didn't want it to. So the case classes are very handy for pattern matching and for creating immutable objects which are equal to each other based on their parameters values. Are the two most basic use cases for case classes. And not writing a new keyword is actually a small benefit, but conceptually very important. So, cool with case classes?
Is
Yes?
it possible to override some generated method?
No. No, not even apply, not even apply. It's all or nothing. You get your case class, and what you get, you keep. You may write another unapply method, but the one that's generated for you is there. The same for apply.
So I have another question. When I have like a class, a case class, and I extend another class, can I do that?
In the Scala 2.9, you are able to create a subclass of a case class,
Okay.
but you got a warning from compiler. Watch using the equals method because it stops to be symmetric at the moment.
Okay. Yes.
If you read, for example, the effective Java, there is a huge chapter, the equals method, and how to write it and what to be aware of. One of it is that if you have equals method in a case class A, there is an equals which returns true if the other is A2 and all the matches, and you create B, then it stops to work.
Mm-hmm.
It stops to be symmetric. So in version 2.10, you cannot subclass case classes. The compiler will let you because it makes more evil than good.
Mm-hmm.
But a case class can extend.
Yes, case class can extend anything. And there is one more thing. I have told you that the compiler is able to check your code, check your match expression if the match is exhaustive. For example, if you have a number and match it, would this match be exhaustive? The answer is obvious, so don't be shy to say it aloud.
What do you mean by exhaustive?
Can some value of num throw an exception while put into this expression? Yes, if it's not 42, it will not match anything. Not every answer is 42 in real life, so it will throw and match error. If you put case like this match is exhaustive because any other value other than 42 will end up here and will match against anything. So this is exhaustive, and the compiler is okay with that. If you leave out the default case, then the compiler will tell you, okay, if you don't get 42, you get a problem. So better look at the code if it's okay. And if you know, I will always get 42 here, you may suppress this warning with a notation. But if you're not, you would better put some other branch. And now, let's imagine you have this code. We have a trait wealth that represents how rich superhero's alter ego is. And it's either class cash with the amount of integer, or it's an object of fortune which represents a lot, which is not representable by an integer. It's a lot. Tony Stark is a very rich guy, and $2 billion does not represent his wealth. So we decided to make this model. And you know, these are the only two possibilities of wealth. There is none else. So let's say you are matching against someone's wealth, and it's either cash with some amount or it's a fortune. And what does the compiler say to you? That the match is not exhaustive. What if the wealth is something else? And you know, no, it cannot be something else, either cash or fortune. It's okay. And the compiler is still winning. You need to put your default. So okay, you put the default case, which really does make nothing because it can be never ever reached. So the author of the languages chose to say to the compiler, yes, that is okay. The wealth might be idle cash or fortune, and that's it. And you can say by putting a sealed keyword in front of the trade or something else. So this tells the compiler all of the subclasses of wealth are in this file, and there will never ever be any other. And if it will, in another file, the compiler says, okay, this does not compile because the wealth is sealed in this particular file. So you have under your own control how many subclasses of the wealth you have. Compiler knows them all in advance because there never ever can be any other in another file because it's sealed, and it stopped winning, and you may write your code a bit nicer. So there is a concept of sealed trade. It breaks one convention of Java that you put each class into its own file. In Scala there are cases where you cannot put each class into its own file because you have to put multiple classes in one. But usually you use this concept when those classes are case classes and they usually fit onto one line. So it will be, I don't know, 5 or 10 lines of code in one file. That's totally okay. So in Scala there is no such convention of putting one class per file, or it might be a convention which might be broken, but it's not enforced by the compilers. So this is the sealed class. Yes?
So will it be okay if I omit the case fortune in the match?
If you omit this case fortune, now the compiler knows, yes, you match cash, but you don't match fortune. You have honest host with pattern matches. So you need to do something. You can put wrong one. You can put this. Or
if I don't put this, the compiler will go through an error?
no, warning. It will emit a warning.
Okay.
Because the logic of your program might be that this is always a cache, but it's of type wealth, but it works like this, so it's a warning. It might be a fortune. If it is, you get a match error. So it's just a warning. It will guide you to make no mistakes. And the compiler knows, with the sealed keyword, it has all the information. Okay. If you have a hammer in your hand, everything looks like a nail. And if you have a horse hammer, everything is a nail. And the pattern matching and case classes might look like a horse hammer to someone and need you to overuse it. And in Scala, there are always multiple ways for each problem to solve it. And pattern matching is not always the good one. So once you master case classes and pattern matching, you might have the urge to put it anywhere, even places where it's not really fit. So no, pattern matching is not Thor's hammer, but it's a very powerful tool. Do you have questions? Don't ask the guy, he doesn't want to be asked questions, but I can. Yes?
I understood case classes right, they are basically independent.
Yes, yes, yes.
So is there anything like, say, in journaling as strings in Java? Is there any similar mechanism implemented?
Did I answer the question? Sorry. No. The question is the instances are singletons, basically, right? Like in strings in Java, if you write a string literal, that exists in one instance.
So we may be able to do to create an instance every time.
No, because as we have seen the apply method in the case class, it calls the constructor, it calls new, so it will create.
Yeah, it was just running.
Yeah.
Perhaps there's something with the public.
No, it's not. There is one more thing I want you to note. It's a peculiarity. Do you know what an object is? The object keyword. Why don't I realize that you know it? The object keyword. Yes and no. It's an object. It will create a class called function $, for the JVM, and make sure it will create an instance of it, which is called fortune, at least at the moment when it's first accessed. So it's lazily accessed, lazily created. So yes, there is a singleton pattern used, but if the object is used inside of a class X, and inside is an object epsilon, then X, A, B, new X, then A epsilon is not B epsilon. These are two different epsilons. It's an object, but there is a singleton within an instance of an X class. So it's not an singleton. Usually it is in its own context, which is usually in a package. But if it's inside of a class, it's not a singleton. Now, as many epsilon instances, as many X instances. So, what the case keyword inside of the object brings you.
Immutable.
It is immutable by definition. It's only one fortune. Can't change. There's no way how to change it. There is no need for apply method because you can access the fortune value by its name. So no immutability, no need for a val because it has no parameters. So no val, no apply. What about unapply? There is no need for unapply because it's a constant pattern. There is only one fortune. What about equals? There is no need for equals. The fortune can equal only to fortune, that's it, everything else is false. No equals. What about hash code? We don't really care about hash code when there is no equals. So let's be good with the default implementation of Java. Some hash code for our only one fortune is cool, fine. What about copy? There is no need for copy, there is only one fortune. So what do we get with this case keyword? ToString. Yes, that's it. You get ToString. So you may use the case keyword inside of the object if you want to print it on the console and see this name. Otherwise, you would gain some, how ToString in Java is generated, some hash stuff, and add sign and the fortune $, which is somewhere under the hood. You can't see. This was just one picture thing. And the equals still doesn't work in this case. Yeah? If the epsilon will be a case object, in this case, this still wouldn't work. These are still two different objects. It doesn't matter when you put a case inside of it. So that would be it for the case classes of auto-matching. Yes?
Do you have any performance comparison if it is faster to do the image patterns instead of do it in Java?
The ugly code I've shown you at the start is basically what you get if you pattern match. But it's something more, it's more general. Basically you need to check the type, and if it is, you need to typecast it, and then extract the values one by one. So I'm not sure if there is some significant performance stuff. But the code that is generated for the pattern matching is quite big, and there is a constraint that the case class can have at most 22 parameters, not more. Because someone found out that if it was 23, there is some non-trivial probability that in some usual pattern matches the generated code would be so huge that it wouldn't fit the maximum of the Java method JVM. So someone said 22 is good. It's good. And the same goes for tuples. Tuples are case classes too, so they have the limit of 22 parameters. So let me invite you for the next event, for the May meetup. These two guys, Jakub and Vlasta, will tell you about the new things in Java 8. And because we are a Scala user group, it will be aimed at the comparison with Scala and how it can help improve Scala. Because Scala is much more powerful than Java, but it has to compile into Java bytecode and has to make use of the usual JVM features. And the Java 8 might bring some more that might help Scala be even more performant. And Jakub will tell you about Scala 2.10, it's the newest release. I think it was this January. Was released Scala 2.10. And it brought some pretty interesting language features. These are some of them that we'll be talking about. And if you want to code, I don't know how many of you coded today, we're having a coding dojo in 3 weeks, 2 weeks, 3 weeks. This is an actual photo of the April event. You can see 18 people came and everybody coded. And we tried a new format that the people are split into small groups according to their skill levels, and they choose their own problem to code. So if you are newbies, you may choose something very easy to code just to get familiar with language. If you are expert, you may choose something more challenging. It's up to you. So everyone is able to learn something and to teach others something. It was a very nice atmosphere. So we got guys who coded complex numbers in Scala, guys who saw Scala for the first time in their life. It was tremendous. We had guys who coded some asynchronous access to the MongoDB database. So it's really very diverse. And what you don't see there were some pizzas and codes brought to you by Etnetra company who sponsors these events. So this is not on the meetup yet. I will put it there this evening, and you are free to join. There is a limited capacity of 25 people, which is exactly the number of the chairs in this room. So we will be glad to see you again. Thank you.